Alrighty, welcome to Arithmetic Sequences Part 2, our second look at sequences. And I've put a little question right on the page here to start with. It says, find the arithmetic sequence if term 5 equals 16 and term 11 equals 11.5. Now when they say finding a sequence, they mean find the first three terms, and that kind of sets the tone for the whole sequence. So the key word here is arithmetic. So I read that and I go, you know what? Arithmetic sequences, we have this formula here to work with. And we also have our knowledge of how these sequences work. So what I'm going to do is I'm going to write down, well, I don't know term 1, 2, 3, or 4, but I do know term 5 has a value of 16. And then I don't know term 6, 7, 8, 9, or 10, but I do know that the 11th term is 11.5. And then after that, I don't really care. So here's kind of just a little sketch of what the sequence would look like, and I'm really after trying to figure out these first three terms. So the key to the whole thing is it's arithmetic, and I got to kind of leapfrog my way along from 16 all the way up to 11.5. Well, let me just show you how this works. To get to the next term, I know that that's 16 plus one common difference. To get to this next term after that, I know that's going to be 16 plus two common differences, and so on. So I don't have room to write it all, but this would be three common differences, 4, 5, and finally, to get to here, this would be 6 common differences. So in other words, I would have 16 plus 6 common differences, and that would end up equaling 11.5. Now, if you look at what you have here, you have a great little equation that you can now solve for D. So let's take 16 and subtract that from both sides. So 6D equals negative 4.5. And then I'm going to divide by 6. So my answer is going to be negative 0.75. So I just figured out the common difference. Okay, now I could work my way backwards. If moving to the right means I'm subtracting or adding negative 0.75, then to go in the opposite direction, to go to the left, I would be adding positive 0.75. So I could do that, but let me just show you another approach. Suppose that was a little bit too many steps to go and I didn't want to take a chance. Well, I can go back to our formula here and pick one of these terms, doesn't matter which one. I'd probably take term 5 here because it doesn't involve any decimals. And what I can do is this. I can say, well, term 5 has a value of 16, and I don't know what A is, but I do know if it's term 5 that N is 5, so I have 5 minus 1, and I got my common difference here of negative 0.75. So again, I'm creating an equation now that has one unknown. Well, let's simplify it a little bit, and I think we can figure out what A is. So this is going to be 4, and 4 times negative 0.75 is actually just going to be minus 3. So all I got to do is add 3 over, and it turns out A must be 19. So what have I got? Well, my first term is 19. And so if I'm going to add to that a common difference of negative 0.75, then my next term is going to be 18.25. And my third term, I'm going to add another negative 0.75, so that's 17.5, and so on. Now, the way you'd want your answer to kind of look would be like this. This got a little bit squished up here, so 19 and then 18.25, comma, then 17.5, and then dot, dot, dot. So this is the ultimate answer as far as I have figured out this arithmetic sequence that has terms 16 and 11.5. So there's my first example. And I'm going to do one more example here, and then I'm going to stop with part 2. In this example, things are a little bit more abstract here. So let me just show you what's going on. So we have an arithmetic sequence. So they have to tell you that. Otherwise, how do you know that it's arithmetic, right? If it's not arithmetic, we have no way of guessing how the sequence works. And they tell us that, well, we got this as a term. Maybe it's our first term. And then we have this as the term right after it. Okay, so this is very abstract. And then the term right after that, 4x plus 2, ... So we go, oh man, is that ever nebulous? Okay, so how do I proceed? Well, how do you go from one term to the next when it's arithmetic? I think what we do is we simply add d. Right? We add d, and that gives us the next term. Okay, so that's an equation. Now, it's got two unknowns. I can't solve it, but I could isolate d. So what I'm going to do is take x away from both sides and add 1. So a little bit of rearranging here. D equals x plus 5. Okay, now let's look at, we got more information. How do we go from the second term to the third term? Well, it's the same thing. I'm going to go 2x plus 4, and I'm going to add d to that. And that's going to give me the term right after it. And yet again, I can isolate d. So d is equal, we're going to take 2 x's away from both sides, 2x, and we're going to subtract 4. So minus 2. Now, if the equation on the right and the equation on the left both equal d, then I can do this. I can say that x plus 5 must equal 2x minus 2. And that becomes a really easy equation to solve. In fact, all I got to do is take an x away from both sides. So there's x, and I'm going to add the 2 over. So x turns out to be 7. Now, I didn't put a question down here. If they just said find x, which sometimes that's all they want, you'd go, okay, no problem, done. If they said find the sequence, so find the sequence, okay, well, that's a little different. How would I do that? I would have to use this x value and plug it in to figure out what the numbers are. So the first one would be 7 minus 1, or 6. The next one would be 2 times 7, or 14, plus 4. So that would be 18. Okay, and then the last one would be 4 times 7, which is 28, plus 2. So it looks like there's our sequence. Okay, it looks like we're adding 12 each time. So that works, and that's where I'm going to stop.